Have you ever wondered what makes the singing or playing style of a musician so special? One way to figure this is to consider their techniques to articulate, connect, and ornament the notes. Among several ways to analyze them, one is by using powerful visualizations that bring interrelations forward, which other ways may be rather hidden from the ear. Welcome to an introduction to Expressive Means, a WAM plugin for the sound visualization software Sonic Visualiser. Expressive Means detects instances of articulation, pitch vibrato, and portamento within recordings of musical performances. It generates labels which contain the type and some core values of each instance, the respective modulation intensity index, mean values over the whole of the recording. In this example, it's the mean maximum rate of all vibratos found. A pitch track based on Matthias Mauch's Pigeon algorithm, which traces the tone's pitch developments, as well as another layer which highlights the vibrated parts of the tones only. And finally, it provides a wide range of other outputs to describe elements of musical expressivity. Naturally, all this data may be exported for further statistical evaluation and visualization. Please note that Expressive Means works with monophonic audio only in appropriate ways. If you'd like to consider single voices within polyphonic recordings instead, you may consider our YouTube tutorial on that topic first, which presents two ways of limited voice extraction by means of the software Audacity or Isotope RX.
Tannenbaum, oh Tannenbaum, du trägst einen grünen Zweig. Ich hab nicht Mutter noch Vater, der mich versorgen kann.
To start, and if you haven't already, download Sonic Visualiser or its latest update. Then go to the plugins page at github.com/canem/expressive-means. Choose Releases, and you will see a number of files designated for various operating systems. Click the file with your system's name in it. In my case, that would be a Mac OS. Besides that, you will find a brief reference manual, which aside of quick start instructions and a lot of valuable hints and tricks, it explains how the plugins work at their core and, certainly most important, on which base they classify articulation, pitch vibrato, and portamento instances. These classifications are discussed in more detail in the associated chapter of the book Softwaregestützte Interpretationsforschung. Back to the downloads. If you're running a Mac, you might have to bypass Macintosh's safety barrier. Then go back to the files and drag them to your WAM plugin folder within your library. In case of further questions or problems, you may consult Queen Mary's WAM plugin homepage. Now let's have a try. Load your audio to Sonic Visualiser's pane. In our example, we will be listening to Fritz Kreisler's 1936 interpretation of Beethoven's Violin Concerto. We'll consider a small snippet only of the second movement. Let's add a spectrogram first. And then listen to it a little. As can be both heard and seen, Kreisler employs an interesting combination of pitch vibrato, complemented on certain notes by some percussive articulation, done by some kind of left-hand finger-slapping technique, and portamento. We'd now like to know how these elements correspond to each other and how they relate to the score. Let's start with articulation. You'll find the plugins by clicking Transform, Analysis by plugin name, E to I, and there you have two options named Expressive Means. Choose the former for quick and rough analysis based on a knowledge of a few details of the recording only. For a first overview, we'll choose the Articulation Summary output. You'll see a number of semantic parameters now that should be set according to your recording. In our example, the Beethoven concerto is written for a violin, so choosing a treble clef and a string signal type would be most appropriate here. Note durations means the shortest expected durations within the recording. You may estimate this value, or you may make use of Sonic Visualiser's Select tool, that is the little cursor, and simply measure the duration of your shortest notes. The respective value is given in the brackets. In our case, it's 174 milliseconds, so we'll go with the moderate option. The next two parameters may need some experience in estimation. Sound quality refers to the amount of technical artifacts given on an ordinal scale from 1 to 6, where 1 means almost clean and 6 extremely noisy. Since our Kreisler example contains significant amounts of surface noise, but a voice still is clearly in the foreground, we'll go with an in-between value. Comparably, reverb duration may be fairly estimated by some training. However, you may use the Select tool again in order to measure a pitch's reverb duration after offset, which is represented by this little shadow here. In our case, the pitch reverbs for roughly 400 seconds, so the large studio option would be the most suited here. The overlap compensation refers to potential note overlaps, so it should be always ticked on as long as your voice performs legato techniques, as is apparent in Kreisler's performance. Finally, the normalization property is activated by default. Only switch off if your audio is already in level normalized, or if you'd like to analyze very quiet passages. Now, if you set your parameters, hit OK, and you'll see a little processing status bar in the lower left edge of Sonic Visualiser's pane. After some time, depending on the length and the sampling rate of your audio, a new time instance layer appears, which presents the results of the articulation summary output. Essentially, each segmentation line here marks a new onset, and the articulation data associated with the following note is given in multi-line labels on top. Now let's evaluate the performance of the onset detectors first. To do so, we're going to reduce the playback speed a bit, and then listen to how well the onset beats fit the note onsets we hear. I would say the detectors worked pretty well, but in a few instances only, they missed onsets or added false ones. To compensate for that, you may simply delete the latter by Sonic Visualiser's rubber. And add missing ones by the draw tool. Of course, for those instances, you'll need to add a manual analysis later. Now let's have a look at the analysis of the plugin. Each label contains the timestamp of the associated onset and the duration to the next onset, the articulation type, the spectrographic noise ratio during the tone's attack and decay phases in percent, its volume development, that is, the maximum and minimum level differences within the sustain phase, the tone's note duration as a ratio to the inter-onset duration, and finally the type's articulation index in index points. Let's concentrate on the type code first. This one says S increasing L. To decode this string, please consider the reference manual again. Here it says this tone is a sonorous, increasingly loud lungo note. That means a tone that starts with almost no noise, then it becomes louder, as can be seen at this overtone, and there's no gap whatsoever to the following tone. The combined physical intensity of all these moments may be expressed by one single value, the articulation index, which in its core is generated by multiplicative cumulation of the factors given next to each type. In other words, this specific instance features a modulation intensity of 19 index points. To bring these index developments a little bit more forward, you may add an index layer which returns the changing modulation intensities as a graph. Moreover, this layer can be easily exported, for instance to a spreadsheet, to create a better overview and for further statistical evaluation. In case you don't agree with the plugin's analysis, it's of course possible to edit the layer data. For instance, we found this onset to be percussive earlier, that is plosive instead of fricative. We may change the data either by double-clicking the segmentation line or by making use of the advanced mode of the plugins. To do so, click Expressive Means Advanced. And here you will find all the plugins outputs plus some additional ones, allowing you to change the parameters values on the concrete metrical base rather than a semantical one. In our case, we just need to modify the impulse noise ratio parameters a bit to solve the problem for the whole of the recording. Making use of the advanced mode of the plugins may certainly need some practice, but it will save significant amounts of time that otherwise would be spent for manual corrections. Therefore, we would like to strongly encourage you to spend some time on finding the optimal parameter settings for your specific recording. Both the Vibrato and Portamento plugins in principle work the same way as the Articulation plugin. Accordingly, in the Transform menu, you'll find the same basic outputs as for Articulation, of which we'll make use of the summary and index layers again. For both Vibrato and Portamento, you only need to know the clef, the signal type, that is instrumental or vocal, and the shortest note durations within your recording. We are going to hit OK and add an index layer again. The Vibrato summary consists of 7 rows. It returns the timestamp of the onset and the duration to the next onset, the Vibrato type. Here we have a continuous, moderately fast, wide vibrato that is not developing in range. The duration of the detected vibrato elements as ratio of the duration of the full tone. Then the mean vibrato rate, that is its speed in hertz or cycles per second. Its maximum range in cents, where 100 cents equal 1 semitone. the timestamp of the range maximum, as well as the duration of the full tone, and finally its vibrato index and index points. In addition to the vibrato summary and index layers, we recommend to add the vibrato-only pitch track output. This may be especially useful if you'd like to locate a specific vibrato or to trace potential mistakes of the analysis. Finally, let's look at Portamento. As mentioned, the Portamento plugin works on the same premises as the Vibrato plugin. Besides the usual timestamps, its summary output returns the Portamento type. Here we have a descending, slow, medium-wide target Portamento with no loudness variation compared to the start and the target tone. Here we see the Portamento's start pitch and end pitch, as well as its range in cents, its start and end timestamp, as well as its total duration in milliseconds, its maximum and minimum level development in decibel, and finally its index in index points again. Analogous to vibrato, you may add the Portamento significant points output in order to locate Portamento instances with regard to their start and end points. This again may help with refining the plugin's parameters. Eventually, let's try a comparison of the results and come back to our Kreisler recording. To get a fairly good impression, we'll be listening to a longer passage this time, that is bar 40 to 57 of the second movement. In Sonic Visualiser's pane, you'll see the summary and index outputs of each articulation, vibrato and portamento. All of them have been created by the semantic, that is, the quick mode of the plugins, but also note that each of them required slight manual refinements due to the quality of the recording. In the lower left edge of the window, the indices are given as graphs together with the violin part of the score. Let's see how the graphs' developments correspond to both the score and our impression of Kreisler's performance. Did you notice how Kreisler used both his vibrato and articulation intensities to create groups of 4 that support the descending line of the melody? How he uses his portamento to slightly delay the beginning of a new section, and then performs an uninterrupted series of highly extensive vibratos that convey a vigorous idea of the second theme. Sometimes he employs a uniform development across vibrato and articulation to keep the tension. But for the most part, his expressive means seem to be largely independent from each other and following their own specific purpose. Thank you for watching, and please consult the reference manual for some additional advice. You may also consider our mailing list on software-based performance research.